everyone. My name is Matt. I talk really quickly. I apologize. I'm going to try to stay slow, but within like 30 seconds from now, I'm going to forget all about that. So yeah, I've worked on Dask for a very long time. So of these four, I've got a favorite. And actually, I have a totally different talk planned as of like 2 weeks ago. And 2 weeks ago, we started playing some benchmarks. It was really fun. It was a fun collaboration. So I threw out my old talk. It turns out you can go onto like the PyData website and just change your talk description entirely and no one stops you. It shows up instantly on the website. It's great. So we're going to talk about benchmarks. We're going to talk about benchmarks for these projects at large scale, sort of SQL database processing. Tagline is the battle that no one wins. And we're going to try different scales, different environments, and everyone's going to fail in different ways, including Dask. Dask does not win this time. We see lots of charts today. Those charts are going to look. So if you don't like listening to talks, you like looking at results instead, those are the TPC-H.coil.io. I put this up like yesterday. It's not mobile optimized. I apologize. We're looking to look at things like this: local, 10 gigabyte, cloud, 10,000, 10 terabyte. We're going to see what does well in 4 different scales. So it'll be fun. But before that, we're going to be super boring. So I'm going to give some background on TPC-H and on dataframe stuff that maybe you know, maybe you don't know. We'll go to charts, which is super exciting. And it'll talk about like what's slow and why. And that's what's like fun, I think, for the like engineering performance people. Then I'll like sell you some stuff. So again, TPC-H.coil.io if you want. It's got some results there. Okay, background, kind of boring. First, there's pandas. So let's like all give a round of applause for pandas. It is like, aside from Excel, it's probably the package that like has had the most impact on the earth, or among the like data analysis people. But pandas do not operate at like the 10 terabyte scale in the cloud. And there are other options that people use today, or people are curious about using today. Historically, people used Spark, and Spark is definitely the standard in the space. There's Dask. Dask is like lots of things that aren't databasey, but if you sort of add Dask and pandas, this is that dataframe thing, which does sort of more dataframe kinds of stuff. There's DuckDB and Polars, which are both really well off. So Spark and Dask, both are distributed computing systems. They're both a little bit older, they're both a little bit slower. DuckDB and Polars, they come on to like lightning fast on a single machine. And it's interesting to see sort of where they fall down, where they succeed. So different things. Historically, putting my Dask hat here, Dask has sucked at benchmarks. It is like very easy to use Dask poorly, and it's a very popular project. So you like want to show that your project is better than the incumbent, include Dask in your benchmark. Recently, though, a bunch of things happened with Dask. Pandas got a lot faster with Pandas 2. Other RD types like massively changed memory performance, things like copy and write. We redeveloped our shuffling algorithm, or like sort, join kinds of things, and we're now adding query optimization. And these 4 features actually like create a new Dask dataframe, which is actually kind of fast now, which is fun. Patrick, who's here, gave a talk on this earlier this morning. So Dask and pandas are fast now. Here's a quick video. So if you've used Dask dashboards, you've seen charts like this, and I'm actually showing on the left is like new Dask, and on the right is old Dask. And some things to note. There's some progress bars down here showing you the progress. They're both progressing at the beginning just fine. We're also going to note up here, there's memory use. Here on the old system, it's fine, but it's up to like 30%. On the new system, very nicely bounded memory use, very stable, very clean. On the right, we're seeing a lot of really exciting activity, super fun, but also it's red, it's kind of scary. It's going to slow down a little bit. This memory is creeping up. I'm getting kind of nervous. On the left, really boring. Actually, so if you go up to our booth, we've got this running all the time to try to attract you to the booth because it's exciting. And then the new system sucks because it is so boring. It is like not nearly as flashy as the old system, which has lots of like flashy lights. But yeah, so the old system now is kind of scary. It's orange. It's yelling at you. It's spilling the disk in a bad way. The system on the left is just chugging along. So this is a difference to sort of think about in Dask. If you're familiar with Dask historically, you've used it at a large scale, you've seen slow things like what's on the right. And today, you'll see boring and fast things. I'll like what's in the So, again, Dask and Dask are fast now, boringly so. That is our goal. So, but let's talk a little bit about, not Dask, but the benchmark suite we're going to play with. So there is an organization, TPC, which manages a variety of standard benchmarks in the sort of tabular SQL database space. TPC-H is a database benchmark, which is very standard. Many people implement it and they compare against each other. And it is very sort of join, sorting, group aggregation heavy. Honestly, the stuff like pandas and Dask don't get used for that often. This is more for like a serious SQL database. But other people did it, so we're sort of copying it. Just fine with it. The queries look like this. You can't see this is way too small. But they're complex queries with lots of merges, lots of joins, lots of sort of complex behaviors. So that's the queries that we're going to run. We're going to run those queries on a variety of scales, ranging from 10 gigabyte to 10 terabytes. So there's a 1000x range there. And we're going to run it on my MacBook Pro or on a bunch of machines in the cloud. Those are the different environments we're going to play with. And we're going to see how that operates. My MacBook Pro is about 2 years old, it's got an M1 chip. It's like running Chrome in the background. I haven't cleaned everything up. It's simulating a busy data science workspace environment. On Amazon, we were running an M6i, which is a standard chipset until yesterday when some company stole all of them. And we had to switch to a different chipset companies, which you can do on Coil really easily. But it's like a very boring choice. Okay. We're going to keep the number of cores and thus the cost constant across all systems. We're going to use DuckDB and polars on a single machine because that's what they can do, and Dask and Spark use on many small machines because that's kind of sort of just want to see the benefits and drawbacks of distributed computing. So that's this is the landscape of the compute environment. Again, these are our projects. I really don't like benchmarks because people cheat unintentionally, right? They cheat unintentionally a few ways. You keep tuning until you win, and then you publish. You don't publish ahead of time. There's a strong publication bias. You also focus on where you win. So like in this talk, I'm going to talk way more about cloud and way more about scale, because what I think is really important. If Richie were here, is Richie here? No. If Richie were here, he would focus way more on single machines in memory, 10 gigabytes. We've actually been collaborating a bunch. So there's we're all sort of working together, it's fun. And then finally, I'm just way better at Dask than you are. And I'm way worse at Spark and DuckDB and polars than those relative authors are. And so I can just navigate the Dask space way better. We're gonna see actually, I think I'm doing Spark wrong. Spark does not perform well in these benchmarks as well as I would expect. I expect this because I'm dumb, not because Spark is bad. And Patrick just whispered, I disagree. So we're trying to address this bias in 2 ways. We didn't choose the benchmark suite, we chose whatever polars did. We didn't write the queries, we chose what polars did. The data generation we didn't do, we sold from DuckDB. And we're avoiding configuration options. I can actually configure Dask to run about twice as fast as I'm gonna show you if I super saturate some cores in some situations and use configurations often in others. So we're trying to be honest, but that's impossible. We're not going to be honest. It's the bias is a thing. So to address that bias though, we're working with polars people. So this is Richie and I, who spent a lot of time with the last couple of days. We actually got polars S3 access to be 2 to 3 times faster in the last few days. It was super fun. We've I think released polars 2 or 3 times also in the last few days, trying to get these things better. Polars would like you to know, Richie would like you to know, Richie is the polars guy. Richie would like you to know that this is using the polars streaming engine, the out-of-core system, which is way newer and isn't as optimized. He'd also like you to know that or I want you to know that polars is younger than everyone else and is moving really fast. So polars will also not perform very well at large scale, but that's mostly just because of timing. For Spark, we're talking to a company called Sync Computing, super cool company. They look through your Spark logs, do a bunch of magic, and then tell you what configuration you want for Spark jobs. Fun group, they do a lot of Spark. We're mostly talking to this guy Vinu, who's on the right, super cool guy. He's from Palantir, optimizing all of their customer Spark workloads. Our attempts at configuring Spark were very bad. They're now better, but I assume there's still a lot of good. We'll see some things about So some charts. That was boring stuff. Thank you for being boring with me. Let's look at some charts. So I'm going to start with local on 10 gigabyte. Dask is on the left, that's blue. Spark is on the right, and that's light blue. Those are the distributed systems, and they're going to correlate. The distributed systems and the single machine systems will behave somewhat similarly to each other. DuckDB is orange, and Polars is red. They're in the middle. They're doing way better. Dask and Spark get their butts handed to them at this scale. I will say I was actually kind of happy that Dask was not way worse than Spark. We expected to be worse than Spark, but we weren't. Historically, we've been way worse in performance. People have used Dask as like the easy, familiar choice, not because it's the fast choice. And it's actually sometimes the fast choice now, which is fun. As we scale up to 100 gigabytes, things get weird. I want to emphasize this is on my MacBook Pro, and it's like running Chrome and other crap in the background. And some of these systems are not designed to run with a bunch of other crap in the background. So like in some cases, like PySpark actually just fails. This is, I think, because PySpark is expecting my entire machine, and it like has weird swapping errors that I get a bunch. But DuckDB, Polar's doing pretty well. Polar's kind of has a hard time at the 37. 37 has a lot of weird large joins. DuckDB also doesn't do particularly well there. I'm going to shift now. When we go back to query to 10 gigabytes, and we're going to shift to cloud. So this is showing you the difference. When you switch to cloud, everything is normalized. And we're going to see this in a bit. This is S3 access. So we were reading that from S3. We're doing the query off of that. And S3 is such a bottleneck that all like the super fast high performance magic that new systems have doesn't actually play into things that much. We're actually going to see that managing S3 is actually how you win these benchmarks on large scale. Still, the scale, those sort of single machine systems do pretty well. Polars couldn't do query 2. This is depending on which version we run, either query 2 or query 3 doesn't work with Polars. Switch up to 100 gigabytes. And now Dask and Spark start coming into more of a dominant play. As we increase scale, the more scalable systems can do better, which is not surprising. Dask is faster than Spark. This is not what we expected. Most of the time, actually, in these benchmarks all the time. We're happy. Like mostly we competing against Spark. We're very happy to see this. If you use Spark today and want to care about speed and like ease of use and friendliness, you should use Dask today. Going up to 1,000 gigabytes. PySpark and Polars have some problems. Dask and DuckDB kind of do okay. Really, honestly, the winner over all these things is kind of DuckDB. DuckDB seems to do pretty well at a variety of scales. When I actually switch up to 10 terabytes, I actually couldn't get Spark to run in less than an hour for my like tests would stop running. And DuckDB can handle like 4 of the queries. Dask is also like oddly the only system that runs across all scales and completes all the time. The boring part of the video that I showed you earlier is actually really nice. It just actually runs all the time. So those are the results. I'm going to now get into sort of more analysis mode. We're going to talk through what we're seeing and what's good and what's bad. So so first, no tool wins consistently. You should make different choices based on your environment, based on your experience level, based on if you like SQL or don't like SQL, if on one machine or many machines, if you're in the cloud or not the cloud. No single machine, no single system is right all the time. And also, no one is anywhere near optimal on cloud. Like Dask does pretty well on cloud, and we've found like a 2 to 5x speed improvements that I think are available to us. Like I can show you how Dask is dog slow right now. And the fact that we are neck and neck with everybody means that everyone else is also dog slow. It's very, I am surprised at how bad you all are on cloud access. So let's talk about S3. So these are all running on Coil. I can go look at my Coil dashboard. I can go look at workloads. Sorry, there's like some feedback. I apologize. I cannot fix that. This is showing you the 7 queries that were run with Dask. Query 1, query 2, query 3, etc. And we can see the sort of kinds of activities we're doing across time. If we look at the baseline metrics during those time, we see CPU use, we see memory use, we also see network access. focus also on network access for a second. On query one, which is mostly just downloading data doing group aggregation, we get about 50 megabytes per second, 60 megabytes per second per node. We have a bunch of nodes, so it adds up to bigger than that. But I honestly expect more like 500 megabytes per second per node on these kinds of machines. So we are not operating anywhere near performance limits. Oddly, if you track this down, it's actually Arrow. Arrow is surprisingly fast on my MacBook Pro and surprisingly slow on a Linux machine in the cloud. We did like a bunch of collaboration with the Arrow folks over the last week. They're like, are aware of the problem, they're all offsite right now, but hopefully over the next few weeks, we can make this a lot faster. Things are strange. What's also interesting though is that like it's not just us that it's slow. So also, weird things. I was just running experiments, just downloading bytes. No Dask, no Pandas, no Parquet, just downloading bytes. And I can get like, on a tiny machine, I can get, doing dumb things, 100 megabytes per second. Then it switches to 200 megabytes per second, a few minutes in. Like Amazon does strange things with bandwidth shaping. It's a little bizarre. If we look at projects like DuckDB, DuckDB is on a massive instance. Its CPU utilization is super low. It doesn't need the size of instance, but it does do a great job of grabbing, a gigabyte per second, and it climbs up here to like, 2 gigabytes per second on that machine. DuckDB has handled S3 access really, really well. But Dask, even though it's kind of crappy on one machine, we aggregate over many machines, we actually get, you're peaking at about like 7 gigabytes per second. So Dask sucks at S3 bandwidth, but because we're able to distribute, we can still outcompete a highly optimized system. Because S3 bandwidth doesn't scale linearly with like size of instance type. So this is where I think as we scale up, this is why the distributed systems are doing better. They can spread S3 bandwidth across more machines, but mostly S3 limited. Also of interest, Spark. So here's the Spark one. Spark is also super slow on network. This is our machine. And like 40 megabytes per second, it peaks up here at like 50, maybe 70. Spark is also very, very slow on S3 bandwidth. The difference with Spark is that it's also peaking on CPU utilization. Spark is actually not bottlenecked on their S3 bandwidth. They're getting very bad S3 bandwidth. They're getting very bad S3 bandwidth because they actually are just so inefficient at reading data. Their like in-memory computation is bad. So again, there's like, if you had the performance of DuckDB and the scalability of Spark, that would be very powerful. There's a lot of room for improvement there. If only there was a system that could be fast and scalable at the same time. What are you laughing at? Okay, that's S3 bandwidth. Also briefly talk about inter-machine communication. So this is a profile. So let's look at, again, looking at Dask. This is a Dask hash rate. This is showing you at scale 100, I think, so 100 gigabytes, what all the Dask workers are doing. They're mostly reading Parquet. The blue bits are reading Parquet. The green bits are transferring data in between different workers. This is the cost of being distributed because a lot of time communicating across machines. If we look at actually the profile, so people may not be familiar with flame graph profiles. I apologize. I'm going to exclude you for a second. This chunk, this big thing, is all reading Parquet. This is just us spending time in Arrow trying to grab bytes and deserialize them. This bit over here is inter-machine communication. This is the fact that we are, on many machines, we got to communicate. It's like way slower than this. Parquet speed is way more important than this stuff. This thing right here is pandas. And so like, if you say, oh, like pandas is slow, we need to make pandas faster, it really doesn't matter. Like pandas could be twice as slow and no one would notice because it isn't our bottleneck. Or maybe better to say like pandas is actually fast enough to run all these things really well. Pandas is not the bottleneck. Okay, moving on. Like, except with Spark. Spark is really good at getting high CPU utilization, despite not actually going fast. Like if what you want to do is like keep your CPU's pinned, like Spark is the best tool. Sorry, I'm like trying to be really nice to everybody, but like it's been oddly frustrating working with Spark. Yeah. So anyway, network bandwidth should be like hundreds of megabytes per second. Memory bandwidth, network is 100 gigabytes, 100 megabytes. Memory bandwidth is like tens of gigabytes. Vinny, the Spark guy, actually he was really excited about our dashboard, so you could see all this stuff. Like, wow, that's never had that in Spark. That's awesome. And I was asking him like, great, how do I optimize the network? Like, what are the configuration options to make that better? His answer was like, oh, no one. Like, network is never the bottleneck. It's always CPU and memory use. We're always optimizing for CPU and memory use. That's the slow part of Spark, which is crazy to me. Because again, like these numbers, like memory and CPU should be operating orders of magnitude faster than network. And the fact that they're not is very confusing. And there's a lot of room for opportunity beyond what Spark does. Okay, other takeaway, DuckDB performs admirably from small scale to large scale. They ran every query pretty well up until sort of the 10 terabyte range, which honestly probably what it's designed for. And it did really well at local scale. So kudos to DuckDB. It was like a winner in aggregate across this benchmark. It's them for now. Dask is okay. We're bottlenecked by S3 narrow, bottlenecked by shuffling. Actually, a lot of room for improvement in both of those. We've been doing this for like 2 weeks now. I'm actually really excited about taking those numbers way down. There's actually a lot of space for us there. We're not that bottlenecked by Pandas. Pandas is actually doing their job pretty well these days. So last topic is deployment, where I try to sell you stuff. So I work at a company called Coiled, which is like a Dask company. We mostly sell Dask stuff. And we make it really easy to run Dask in the cloud. And we built a system that makes it easy to turn on machines and easy to get software on those machines, easy to run Dask on those machines. That's like really accessible to people without understanding a lot of like deep technology. And what we found, so like if you ask for, actually I'm gonna just do this live. If you ask for, maybe we'll ask for 100 workers with 64 megabytes each. We'll do this in Frankfurt. And we'll use ARM because I like ARM. I'm just doing this from Python from my laptop. And what this is doing is it is scraping my laptop, depending on what packages I have. It's making a specification that it can ship up to the cloud. It's then going to provision 100 machines. This machine's going to come on in about a minute. They're going to download all those packages and connect it to that securely. So I can, from Python, create whatever infrastructure I want. And I can then run compute stuff on that pretty well. Super powerful, Dask users love it. It's like the easiest way to get machines. What we found, oddly, is that people were using coiled clusters, but the median cluster size wasn't 100 or 10, it was 1. And they did a big Dask dataframe computation. They just ran a single Python function, and they shut down the cluster. Like, what is going on? Why are you using a distributed framework to just run a single Python function in the cloud? And it turns out they just wanted an AWS Lambda that was sensible. And so what we say internally is our core competency these days is actually just turning servers on and off, and making sure they have the right software installed. And so it actually is an interesting growth area for us. So we think of this sort of being the heavyweight serverless option. This is actually how I ran all the benchmarks with DuckDB and Coiled. We actually Patrick wrote a blog post about DuckDB on Coiled, and a bunch of random people started showing up running DuckDB on Coiled and paying us money. It was neat. So we turn that into an API. You just decorate your function with the hardware you want. First time it runs, creates a VM. All subsequent times, it just runs pretty much instantly. And you can run it in parallel if you want. So it's cool relative to Amazon. Lambda is a minute long spin up time. So you should only use this with big things. But if you're cool with that minute long spin up time, it's great because you get whatever hardware you want. You want A100, if you can find one, go for it. It's 10x cheaper than Amazon Lambda. Amazon Lambda markup is huge. And it's just good for just general bulk data processing. So it's neat, it's been fun. There's lots of examples I could show you. You want a GPU in your MacBook Pro, decorate a function with a GPU type, good to go. This is how we ran tests with DuckDB and Coiled. This is all just a PyTest test suite. And I'm just annotating the PyTest function with Coiled functions, and it just runs in the cloud instead, which is neat. It's been a nice sort of composable tool. You can do this with prefect, annotate their prefect task, and it just starts running on a big machine elsewhere. So it's been fun. So I can run Dask because I've got coiled, and I can run now DuckDB and Polar, so these like single machine systems also on coiled due to this service function thing. How to run Spark? The options were like figure out Amazon EMR or use Databricks. Those were both like unpleasant options. And it turns out it was actually easier for us to just reinvent EMR on coiled. EMR is a service to run Spark on Amazon. It was easier for us to like reinvent this on coiled. So this was originally planned to be an April Fool's joke. But actually it was like not that hard to build. And so now it's like build Spark on Coil. It's neat. I can like spin up a cluster, a Spark cluster in a couple minutes, and like drive it from my laptop. So, you shouldn't use this. It's like kind of just for this project, but you could. It's I think a better experience than anymore. So very briefly, that's dataframe pitch. And is still cool. So like putting on my like Dask bias hat here, for example. Dask is the only project that ran all of the queries, and it ran them in sensible time. No other project able to do that. That's my like current claim to fame. It was the fastest at large scale, but probably were being done. Probably Spark can do these things. I'm just not finding the right configuration option. There's a lot of future work for us to do to actually figure out what's going on here. Again, all of this is very new and fresh. These are all very preliminary results. Please don't like. I was about to say, please don't take this to your boss and say that Dask is the best, but actually that would be okay. But know that it will get even better over time. Yeah, and I think mostly like I'm excited about this possibility of getting the scalability of Spark, but without the like 10x slowdown that Spark seems to experience on a single machine. Like if we got to be like half the speed of Polar's DuckDB in memory, that would be a fantastic result, I think. And I think an achievable one. For coiled, you should use us, spend money, we're great. The cloud can actually be really easy and really cheap. It was like easy to build this benchmark system where I'm spinning up all these machines, running all these different scales, all these different data types, and have all run in a PyTest fixture. You too can do that. Coiled makes it really fun. So that's it. That's my one. We have, so you shall all applaud now. Turn that on. So we've got, I think, 10 minutes for questions. Questions? Just raise your hand, wait for the gentleman to give you a mic, and then raise your hand to be the next person so we can like, you know what's going on.
So my question is regarding the benchmarks. So you mentioned that S3 was acting as a bottleneck. I want to know like what was your networking setup for running those benchmarks? Did you set up some TPC endpoint or something of the sort, or do you go over the internet? Because your bottleneck could be there, but going through the internet could still eliminate.
Yeah. So these are EC2 instances on the region that is where the data is stored. So I'm like doing a direct, like this is how everybody operates. But
It depends. Like if you set up the private link or VPC endpoint,
this is not using private link or anything like that.
You're not using that.
Correct.
Because your bottleneck would be there because the EC2 instance has to go through the internet in order to get to S3.
I agree if you're using like private link, that would be a bottleneck, but we're not. This is like Coil generally does very raw cloud infrastructure. You turn on these 2 instances for you as fast as one can turn them on. You download some of them as fast as one can do so. And we just give you just like a raw EC2 S3 option. Good question. You're pointing out that there's a lot of possible complexity in doing this. In general, like the Coiled cloud infrastructure engineers are pretty good at doing this. They like set up pretty sensible things. You can like really shoot yourself in the foot in the cloud if you don't set up networking correctly. It can be slow, it can also be really expensive.
And also networking depends a lot on the instance type that you choose. I actually myself found like making some right sizing decisions on AWS and suddenly my traffic dropped. And I was like, I'm getting so fired. And it was because of that, because it depends a lot on the instance types.
Yeah, I'm trying to make sure we have a notebook where we test all the different instance types to find the best like bandwidth per dollar thing. Yeah, which is super easy to do with Coil. Go for it.
So you mentioned that of course the plan is to make that faster and scale even better than what it does right now. Can you maybe share a little bit about the roadmap on what's exciting in the next maybe 6-12 months on the development of that?
Sure. If you're on YouTube, go look at Patrick's talk, which talked about all these things. We were supposed to do this actually in reverse order. So you would go into his talk and find all the answers to that question. Great question. The biggest, most exciting thing happening right now is we're adding a lot of query optimization to that dataframe. So we can like push column projections down. We can reorder joins and make things a lot more robustly efficient. Historically, the Dask developers can do amazing performance with Dask, but like non-experts easily shoot themselves in the foot. They have a bad sort of median experience. And we're doing a lot of things to make things a lot more robust. That sort of median developer experience. So that's high-level query optimization. That's things like faster shuffling algorithms. Generally avoiding any kind of memory overflow, which is why we're super stable, is why we can run everything. So those things. In general, speaking, Dask dataframe is becoming a lot more foolproof. That's maybe the like theme.
Maybe I'm asking something that you don't know right now, but is there any plans? Are there any plans on adding another kind of data type, so like arrays, data frames, maybe I don't know, something similar to DuckDB or something like can? I guess I'm asking for a lot here, but like can Dask add like an extra data type, an extra class?
Yeah. So the question is, can Dask add new data types like structs, like arrays, like lists inside of Dask data frame? And the answer is, so first, Dask does many things. Like Dask does workflow management and multidimensional array stuff at a very large scale. Dask data frame is Dask plus pandas together. And so really the question is, can pandas add those things? The answer is yes. Pandas can add those things with arrow extension data types. So arrow has all the data types you just mentioned, and pandas and arrow are going a lot closer together. And so pandas is getting a lot of that same capabilities because arrow is pushing it forwards. In general, like the Dask space is really messy because there's like 5 different libraries that are all collaborating to make things happen. So yes, we're adding all those things, but actually like Patrick is adding those things and the arrow people are adding those things. And we all benefit from them in this sort of shared community structure. Good question there.
Yeah, I don't know if this is a valid question, but how does this compare with a data warehouse like Snowflake, where they also now have a Python API?
Yeah, great question. So the question is, how does this compare with Snowflake, or just generally data warehouses? Also good to point out that Databricks also has Photon. Wasn't testing Photon, so it's just open source Spark. Photon tends to get about a 2x speed improvement, which I think we can still beat. Yeah, so I don't know. I haven't tested against Snowflake, and that'd be great work to do. In general, I think the data warehouses can often get a lot more like asymptotic better performance because they know a lot more about their data. The tools that we discussed here operate on data they don't own. Sort of this question in data tooling, are they separate or are they sort of all in one? I would expect Snowflake to win as queries got more and more complex, but I also expect Snowflake to become less convenient as organizations get more and more complex. People want to sort of read in data and do XGBoost on it. It's like hard to do with Snowflake. Yeah, generally those are lots of different tools.
So you did not use the Dask query optimizer in these benchmarks?
I 100%.
You did use it?
Yes.
Okay.
Yes.
And
It would be much slower without the query optimizer.
And then another question I had is, you said you use like a CP instance for folders and DuckDB.
Mm-hmm.
Is that with it? So my company just buys everything in-house. So we have like these crazy vertically scaled machines that we run, data frame computations on. Would that be a fair benchmark comparison, or do you think that's a different type of test?
Yeah, so the question is like, look, I work at a company, we just buy massive machines. Do these benchmarks reflect into that environment? Is that roughly? Yeah. No, they don't. You should run benchmarks in that environment that are different, right? This is like my own personal bias. We mostly help companies who are doing large scale data processing on cloud infrastructure. And so this is mostly a talk about doing large scale data processing on cloud infrastructure. Different hardware, different software packages, like interact in different ways. So I would not take these lessons to be broadly applicable. You should do benchmarking in different environments. Yeah.
Is there an issue I can follow on GitHub for the Arrow S3 improvements that you mentioned, or have they not raised the ticket before?
Yeah, no, so this is all here. Parquet serialization these links. If you go to Arrow and look for author and Rocklin, you will
So
find.
you did add it.
Oh no, this like the last couple of weeks were just like me talking to Pandas, Arrow, Polar, Spark people. It was a super fun time. Actually, it's like a really fun collaboration. Also, all these people are European and are making it like 5 a.m. every day. I no offense to Europeans, but like it's annoying sometimes. We should all live in Iceland together. But yeah, there's like a ton of open source stuff on this. And if you go to one of these, it'll link to other issues. And there's lots of notebooks that are, interesting. So, other questions? Okay. Thank you all for your time. In general, benchmarks are fun. I always hated benchmarks because like someone gets up and tells how their tool is best. I hope I kind of achieved in not doing that today. I'm also really excited about the collaboration here. Richie and I actually would like love to work together on like Dask polars at scale beating Spark. They both have that goal. And mostly we're just waiting until we can kill all of the other bottlenecks. And my guess is that's actually not going to happen. My guess is that but all of the bottlenecks will be like 5x faster than Spark, and then everyone will be happy. But it'd be fun. It's fun seeing a lot of collaboration in this space that's non-competitive and that's collaborative, and I'm excited about that. Thank you all.